I think it's a good time now. And hello, everyone. I'm Sumar Priching, welcoming you all back to the TezAsia Hackathon series workshop. TezAsia 3.0 is a month-long hackathon powered by Tezos India in collaboration with Tezos, where our aim is to cater and grow the audience and the ecosystem of Tezos in India and Pan Asia level. This hackathon is specially targeted for to onboard more users who are right now in college and different universities to learn, build, and ship products on Tezos, so that and help the Tezos ecosystem as well as the blockchain ecosystem grow together. So for today's workshop, it will be on introduction to introduction to smart contracts using LIGO Lang. Okay, and today we have a speaker, Susanna Soy. She's a trainer at LIGO Lang. Susanna Soy is an engineer at LIGO Lang. She worked on the type system and now focus on training and hackathons. She will walk you through the first steps of creating a smart contract for Tezos using the JS LIGO Lang. So, welcoming Susanna Soy. I hope
Hi.
you are. Yeah.
All good. So I will be making a practical session. So just checking if you can tell me that you can see my screen. Just waiting for a message from you. Okay, yeah, so I think you can see my screen. Perfect. All right. So we'll be doing a practical session. So I will start with a general presentation of the LIGO programming language. And then we will move on to using the web IDE to code the little contracts live so that you can get your hands started on that. So first little introduction about the Tezos blockchain. So it is a proof of stake blockchain, which means that it's not like Bitcoin, which uses CPU power to establish sort of a fair share of decision among users. It does not expect users to burn CPU cycles for nothing or GPU cycles for nothing. So it's much more eco-friendly than Bitcoin, basically. So yeah, that's a little bit good for some of the concerns we have, like global warming and energy efficiency. It is also a protocol that is designed to evolve. So every 3 months, people can vote on, like participants on the Tezos blockchain can vote on upgrades to decide which ones they accept and which ones they are not okay with. So instead of having the developers saying, okay, everybody switch to the new version on June 21st or something like this, it is a voting system that decides this, and it is all automated, which means that you don't need to believe that the developers are pushing the right version forward. Otherwise, like with, I don't know, Ethereum or Bitcoin, if you update following what the developer said, but the majority of the community doesn't agree with it and doesn't update, then your node will be considered to be cheating because it will be playing by different new rules rather than the old ones that everybody decided to keep using. So every update on Ethereum or Bitcoin is a little bit of a social experiment where people are expected to decide what the majority will decide to use as the new version, whereas in Tezos it's just built in and everybody agrees on which version to use. So yeah, this means that there are no what we call hard forks in the blockchain. Well, there have been a couple at the very beginning when the voting system was not quite working properly yet, but now for like many versions for a few years, this has been running very smoothly. Another important point about the Tezos blockchain is that the developers of the blockchain are using what we call formal methods, which is ways of improving the quality of the code beyond just the standard unit testing or things like this. It allows to certify, to prove mathematically that some parts of the code are bug-free. So not all the code is proven that way, of course. Like that would be a very huge effort. But we are trying to work on having more and more parts of the code which are proven. Now, in a few weeks, at some point, we will be doing a session where I will show you how to formally prove a contract that you wrote. Now, it's a very difficult and complicated task, so you should be expected, if you want to join the session, to have practiced a little bit. But it is also essential for any contract that will be manipulating millions of dollars of value, because you don't want your contract to have a bug in it, especially since you can't update a contract which is on the blockchain. It is there and it is to be trusted by everyone, which means that you can't have some administrator which can just randomly update it without any warning. So formal methods really help strengthening the tools and ensuring that there are that there are as few bugs as possible. If you would like, you can contact the organizers and ask to be notified when that session will happen a little bit in the future, in a few weeks. Um, Finally, one policy of the Tezos Foundation is to have multiple tools to have some healthy competition in the ecosystem of tools. So, for example, there are several programming languages for Tezos, but also for all of the tools, whether it be indexers or other tools, there are most of the time several options that you can choose from, which means that if one ends up having a critical bug, or if there are some political problems with the developers of a tool, or the developers of a tool just decide that the blockchain's interests do not align with their own, we're not stuck with a single solution so it just ensures that you don't put all your eggs in the same basket, basically. This means that we have a healthy ecosystem of tools, and one of these tools is the LIGO programming language. So this is what I'm going to present to you now. So the main language for Tezos is called Michelson, and it is sort of an assembly language. It is a very, very low-level programming language. So here you can see a little bit of an example of Michelson. And it does a few things, but it's not quite clear if you're not well versed in computer science what's happening here. Like, it's not that readable. It is designed to be readable by humans, so it can be debugged at a lower level. It's not completely obfuscated machine code, but it is also not quite the best language to feel comfortable programming in. So in order to develop smart contracts a little bit more elegantly and feeling a little bit more comfortable, there are several high-level programming languages. So LIGO is one of them, and it comes in a few flavors. So Pascal LIGO is an old-school programming language that is very similar to what you would see in textbooks for algorithm examples, etc. So it can be familiar to some people. Camel LIGO is based on the same language that the Tezos system itself is written in, and LIGO itself is written in. So this just ensures a sort of cohesion in the community. But what we're going to do, so this one you can ignore because reason LIGO is decommissioned now, I think. But yeah, what we're going to use is JS LIGO, which is inspired by the syntax of JavaScript, or more accurately by the syntax of TypeScript. But it's just that JavaScript with a few information about the input and output types of your functions. Camel LIGO is the one that you would use if you wanted to use formal methods, indirectly at least. If you're interested in learning more about that, you can join the session in a few weeks, and we will talk about Camel LIGO and Coq LIGO, which is not on this listed on this page, which are experimental languages for having more strengthened bug-free contracts. But for now, we're going to focus on the last one, JS LIGO. So I'm just going to skip a few things which are not that interesting to you, and we're going to we're going to switch to the live session and have a little look at an example programming language. At an example program for JS LIGO. So let me just find where that window is. Let's go here. I'm going to open ligolang.org. So if you could please open in your browser the page ligolang.org. I'll just paste it in the chat. Hopefully it appears on YouTube, etc. for those who are following. But yeah, it's ligolang.org. I'll just wait a minute for everyone to open this. All right, so I'm going to assume that you managed to open this page. And so it should by default have selected here the JS LIGO language. If not, just click on it. So let's have a quick look at the contract which is listed here. I'm going to zoom in a little bit so that we can see better in the beginning. There we go. So this contract comes in a module. So we have namespaces and modules in JS LIGO so that you can structure your code. So you can just mostly ignore this line. Like, I think it's actually optional. So a contract works in a specific way, which is that there is a storage which is on the blockchain, and the code of the contract is on the blockchain. And everything else happens when the contract is called. So when somebody sends a transaction, for example, when somebody makes a transfer to the account with this contract on it, it will trigger the rest of the code. But for now, on the blockchain, we just have an integer in the storage. And this contract is just a counter which can be incremented or decremented or reset to 0, basically. So we're going to have a look at what's happening inside of this. So the storage is stored on the chain as well as the code, as I said. And basically, if you imagine that you're making a bank transfer to, let's say, your landowner because you're paying the rent, and you include a little message which says what your address is, for example, so that the landowner can know who has paid, or you include your name in the message or something like this. Well, you could imagine that on the bank side, there could be a little script that just goes and tick a box next to your rent when you have paid it correctly, all right? So it's an automated little script that is run when money is transferred to the account. Now, you don't need to transfer any actual money. You can also make a transfer of 0 and just trigger an action, which is how this contract works. It doesn't need any money to be transferred to it. But it can do a little bit of processing and updating its information and things like this. So let's have a look at what is the input. So there are 3 possible sub-programs which can be called. So in this contract, we can call 3 subcontracts, if you will. The first one that we can call is increment. The second one is called decrement. And the third one is called reset. You can notice that these are little sub-programs because they're marked with the @entry annotation. So this tells you that it is an entry point, which means that it is a possible main function for the contract. So this contract has 3 main functions: increment, decrement, and reset, which are tagged with @entry, @entry, and @entry. So the inputs for these little subprograms, these little main functions, are an information, which is a parameter, which is, for example, when you were sending your money to your landowner, you could include your name or your address or something like this. This is what it would be. It would appear here, okay, as the first argument. So in this case, the first argument is just, it's not for counting the rent, it's just a counter, and we tell it by how much we want to increment it. So we write delta :int, which tells us that we have an integer called delta, and that will be the parameter that is passed to the contract. For decrement, it's the same. We have this. And for reset, we just have an empty value called unit because it doesn't take a parameter. So you just call it with a fake parameter, which it's like passing null, basically. It's just like giving it null for saying there's nothing important going on here. And the second argument is the storage, which is not supplied by the user, but is supplied by the blockchain. So the user, can imagine a little arrow going in here. The user supplies this when they call the contract, and they send a transaction with an amount of money, usually say 0 for this contract, no money involved, and a value and the name of the function. So the user would call the contract by providing some money, 0, Tez in this case, the name of the function, and a value here. So the blockchain in turn will provide this half of the parameters, so it will just give the current storage, which is the current data which is stored on the blockchain. So it will give us access to this, and what we're supposed to return is this thing. So we're supposed to return a tuple, a list of two values. So it's not exactly a list; it's a tuple. So we're supposed to return two values. One is a list of transfers, because, for example, if you pay your rent, the little script could decide that once you've paid your rent correctly, it's going to send some amount to the landowner, some amount to the taxes, some amount to the water bills, etc. Or you could have a contract for your own personal account, which would decide to send some money for, I don't know, the money that you're setting away for your kids when they go to school, and some money for paying rent, and some money for paying food, and some money for some fun stuff, for example. So these are the outgoing operations, and in this case, we always return an empty list of operations because this contract does not actually, this contract does not actually produce any operations. It does not handle money. But it does update the storage, which is the second parameter. So we take here the old storage, and we're supposed to return the new storage. So here we take the old storage, and here we return the empty list of operations because we're not calling any further contracts or transferring any more money. And we return the updated storage, which is in this case the old storage plus the amount that we've been asked to increment by. For decrements, the behavior is the same, but we return store minus delta. And for reset, we just discard the old storage, which is why it's called underscore like this, or we could just write underscore storage. The underscore at the beginning says we are not interested in this. So we just forget about the old storage, and we just return a new storage, which will always be 0. So after calling the reset entry point with no particular value here, just a sort of a null, which is called unit, we discard the old storage, which was given by the blockchain, and we tell it the new storage is now 0. And this is about it for this little contract. So I'll just give you a minute to let your brains wind down and look at this. And I'm not sure if I can take questions live on this, but if there are any questions, please let me know. And then we'll move on to the practical parts where you will have a little try. And so we'll try live, so you will be able to try the program by yourself and try to make a few changes. You're just waiting if there are any questions, otherwise I will move on. No, Golang has nothing to do with LIGO Lang. LIGO is just a name. In this case, we have a similarity with JavaScript because we're using JS LIGO.
I think that's the only question so far we have. You can continue
Okay.
with the session.
Yep. We'll move on. All right. So if we return to this page, so you should still be in your browser on the ligolang.org page. And now I will invite you to click on Web ID, which is at the top here, top right. Or I think try it gets you to the same. Yeah. So if you click try it, you can just select JS LIGO on web ID, or you can just click web ID at the top. I'll click on this myself, and I'll wait for you to have clicked on this side too. Okay, so I will show you a little bit more what's happening here, including how the unit tests are written.
Suzanne, I
Yeah,
think we have two questions, or actually
yeah.
one question. Can you explain the importance of @ entry in the code?
Of what? Sorry. Oh, at entry. Okay, yes. This declares that it's a main function, basically. So in your program, you don't have only one main function. You can call several functions, and you just put at entry at the top of each function that can be called. If you don't have at entry, it's an utility function that can be called by your own code, but it can't be called directly by users of the program. I hope that answers. And what are the prerequisites for learning this language? Well, I'm mostly giving you the prerequisites. So yeah, just vague knowledge of JavaScript helps definitely, but it's not too complicated otherwise. And yeah, I have explained a little bit how the blockchain works, how it has the storage of your program, basically your data is stored on the blockchain and is passed to you using this store parameter, which is here. And you just need to return an updated version. And yeah, so learning a little bit about the Tezos blockchain in general will help. But for starting and making your first little program here, I think I have given you most of the elements that you need to know. This is a very introductory session, so normally you shouldn't need much in terms of prerequisites, just having some vague knowledge of how to program. All right, I think we're done with the questions. I'm going to go back to here, and so normally you will have clicked the try now button and JS LIGO on web ID. If you click the top right one, you can also just select to open the counter. So here you would create a new project, which you would call counter, and the template you would take increment here. Yeah, that's the one. And syntax JS LIGO, but it's easier if you just... Oh yeah, and you don't have the test with it, so yeah, please click on try it here and JS LIGO on web ID. All right, so I'm gonna let this load. I assume you have all loaded this by now. Just open it, thank you. All right, so we have already seen this part of the program. So just as a quick little reminder, the data which will be Yeah.
Can we zoom a
Oh
little
yes,
bit
yes,
on
yes,
the
yes, yes.
compiler?
Is this better? Yeah, this should be better. Okay, so we have the storage, which is the data which is permanently stored on the blockchain. In our case, it's an integer. We have the return type, which is a list of operations, and a value to an updated value for the permanently stored data. And we declare three main functions: the increment main function, the decrement main function, and the reset main function. The first one takes a delta, and the blockchain provides the old storage, and we return no further transfers, no further money transfers or contract calls, and we return an updated storage, which will be the old storage plus the delta. Same for decrement, but we return the old storage minus the delta. And lastly, we have the reset, which just ignores its parameters and always returns 0 as the new value to be stored on the chain. So now we will try, for starters, to compile it. So I'm just going to try to maximize this, and I'm going to click on the compile button here. and it just tells me where the configuration is, and I'm just going to click compile. It will take a couple of seconds. And I think normally I should have the updated storage coming up. Did it load correctly? Gonna try that. Yeah. Well, that's unfortunate. Seems like we have a small technical issue. All right, I'm gonna. Oh, network error. Okay, let me reload this. Okay, so, oh, come on. Am I still online here? I think I'm still online, yeah. Okay, so it seems like we have a tiny. That is unfortunate. Yep. All right, so normally if we click compile here, it would show us the Michelson code that would appear below. There's another way that you can try LIGO normally. If you go here on the LIGO Lang.org page, there used to be. Oh, there's no Git pod anymore. That's really unfortunate. Okay, I'll have to contact my colleagues to get this fixed ASAP. Sorry about this. Didn't expect this to not work. Yeah, so when clicking dry run, normally we would have a pane which opens on the right and allows us to choose an entry point, for example, increment a value for this and tell it what is the supposed permanently stored value on the blockchain, and we can test our contract like this. But in order to test our contracts, it's a little bit better if we can use a proper test function. So outside of this module, which declares the contract here, the namespace in Inkdeck, I'm just going to zoom out a little bit and hide this pane. Otherwise you can't really see much. Yeah, so outside of this module here, we can declare some tests. So, and then we can run them with, there's a run test button somewhere here on the side. So here we declare two tests, all right? So there's one here and one below. So here the initial storage test, we test that the contract is just working correctly when we don't do anything. So we set that the initial storage, basically the initial value on the blockchain of the storage is 42. And we originate the contract, which means that we start the contract on the blockchain. So we get the contracts named here, Inkdeck here. So we write contract of Inkdeck, and that gives us this contract. And we tell it that the initial storage should be this, and that the amount of money on the contract's account should be 0 TES to start with. And then we just check that if we look at the storage of this new contract that we just created, it should be equal to the initial storage. So it's just a test that tests that if we start it and just look at it immediately, we get what we expect. This is not anything complicated. More interesting is the increment test here. So yeah, we're going to look at this, and we start with the same initial storage. We so we here start the Inkdeck contract, We give it the initial storage that it starts with, the initial value of its permanently stored data, and we say that the money should be 0 as text like this. And then so this is a little conversion thing, you can just ignore it, and then we make a transfer. So this is where we actually make the first money transfer to our contract. So we just transfer one mutes, which is a tiny small value. I think we can just write 0 as mutes here, and it will work just as well. And we tell it to transfer to this contract, and the value that we transfer is increment 1, which is basically telling it, oh, increment 1. And this part will be provided by the blockchain, but we just tell it the name and the value here of the first argument. So we pass it increment 1 like this, and then we check that the updated storage is the initial storage plus 1. So here we could just write equals 43. So now what I would like you to do is to, now that we have seen a little bit how to test it and how to write the contract, I would like you to, so I'm just going to zoom out a little bit. So I would like you to first delete the tests, because for now we don't need them. So you just put them in a comment like this, up /*/. And once you've done this, I will get you through making a small change on the Inkdeck contract. All right. So I will let you do this, and I'll wait a minute, and then we'll move on. So please go to your browser and open this tab, and please comment this bit. All right, so I assume you've had time to do this, to comment out this bit. So let's say that we want to rename our contract and do something else. We want to have a contract that calculates a small amount of interest. So we're going to call it interest here, and we're going to rename it interest in the two other places where we can use.
Can you zoom in a little bit again?
Yep. So I just renamed the contract to interest here. You can do this on your side. And now I will change a couple of things. So the first thing that I'm going to change is that the storage will now be 2 values. So I will declare it to be a record type like this. Not amount, money, right. Okay. I think I need to, no, just. So now I have changed the storage to contain 2 values, the amount of money and the rate at which it grows. And the return type is going to be the same as before. And here we'll do something a little bit more interesting. Okay. Okay, so here we have a slightly modified contract. So instead of calling it increment, also I will call it compound, because we're computing the compound interest. And I have a very approximate formula. Normally it should be a little bit different, but yeah, should have a little exponential in here. But for now, for the demo purposes, we're just going to multiply the amount of money by the rate. So if we have basically every time this thing is called here, we're going to increase the amount of money that is owed or that is stored with a certain rate. Well, that should be stored. So yeah, it's just, of course, this is not actual money here because we are not actually receiving any money, but in a more complex contract, you could check that the paid back money is equal to this, basically. And so the rates could be, for example, 1.1 or 1.05, for example, to have a slow growth. This more reasonable. Okay, so yeah, so we would start at 1,000 meters, for example, and the rate would be, for example, 1.02. So I'm going to delete the other two entry points here because we don't need them anymore. And basically, we just have a little contract here that just computes how much money is owed after a given period of time. So it doesn't do it properly. It doesn't take, normally we would take an extra parameter for the time, which would be here, time, instead of delta. And here we would return the new storage. And normally we should use the time, but let's just say that this is an approximation for now. I don't want to get into interest rate computation for now. Yeah, so I'm just going to wait for you all to have updated your contract so it looks like this, and then as a little exercise, you'll write a new entry point to change the interest rate. So I will let you do this, leave it on my screen for now. You can update what you have on your side, and I'll leave you 4 minutes, and in 4 minutes we'll get back to this and we'll code a new entry point. And of course, I'm going to listen for any questions. I can't see them at the same time as this, so please tell me on the audio channel if there are any questions. Okay, just going to have a peek. No questions. Yes, I was waiting for users to, as I said, I'm waiting for the attendants to update their contract so that it looks like this. Okay, so I will continue now. Um, so what we will do now is that we will have a new entry point for changing the interest rate. So we'll need add entry to say that it's an entry point in the main function. And we will declare it to be change interest rate here, and it will be something, something, store, orange, and we're gonna return the red like this, and here we will have to return, so it will be again a list of the operations, and new storage. And here we will have let new storage equals this, and yeah. So I'd like you to type in this template, and then I'd like you to fill in the dots so that you have a little exercise to, um, yeah, to figure out how to do this little update. So at your keyboards, you can copy this and yeah, return that. So I think I made a typo here. I need to now return this. Otherwise, it won't work. This and same for this one. Just a tiny change. So yeah, so I'm going to let you do this, and then I'll give you the solution in in 10 minutes, and I think that will conclude our first little tour. I would have liked to continue a little bit more, but yeah, there's a problem with the compile button here, so we can't really do much right now. But there will be another session tomorrow, so yeah, we can go a little bit further tomorrow. But for now, let's just have you write a new little entry point. And yeah, of course, if there are any questions, just tell me and I'll listen for them, but I can't see because if I see, I can't show you the code. So, yeah.
Yeah, I think there are some questions right now. I will just check on and go through all the links, all the questions that are there in the chat.
Okay, sure.
Just okay. And although we have covered most of the questions during the session, there are some questions aside from that also I will cover. But before that,
Sure.
everyone who are there in the live stream, like if you have any doubts related to LIGO Lang or what we have programmed right now, please feel free to first ping it in the comment section, and we will having a doubt. We will have a doubt section.
Yep, perfect. I'll just go back to the program so that
Yeah.
people can try it out.
Also, like there are some questions from Divya and Raghav Fish. So I will just clear your doubts. So first question will be, yeah, you are free to build on any product, any like on any idea. If that's not aligning with the problem statement, but you think that if it can revolutionize the blockchain ecosystem, you are free to go. The only condition for this hackathon is you have to build your product or your project on top of Tezos blocks. So the first question is if you can build on your project using Solidity. No, you can't use Solidity for this because because Solidity is used for EVM compatible chains, but this also is a separate thing. So you can use any language that helps you to build on top of Tezos. You can use LIGO Lang also. In LIGO Lang, you have four different versions: Camel LIGO, Pascal LIGO, JS LIGO, and then you can also use SmartPy. You can use Archetype also. You can use PyTezos also if you have. If you want to explore it, there are you can go through the docs also. We will share the link also in the comment section, as well as if you have any doubt or other things, just join our Discord server. We have shared the link in the comment section. I will just ping it here once again. Just a second. Uh, and you can ask all your queries there. We have a resources channel also where you can find all the resources collectively. For creating a team, you can message in team up channel where you can share all the details about you and who you are looking for. Okay, and other thing, just let us know. So I think most of the doubts are cleared now. Any other doubts related to code, please share. We will be happy to we will be happy to help you. Any questions? I think so. You have already mentioned all things very well. So we hope that everyone understood, and thank you so much for sharing this knowledge. And we will see you tomorrow also with the second part of this session, and we will cover up all the things later on with in continuation to this session. So if in case someone missed the live stream and going to start from scratch, first watch this video and then jump to the part.
Okay, I'm just going to give the solution for the little problem that I had, and then we can close this. Um,
Then you want
so
to say something? You want to share something?
yes, I'm just going to show the solution for this little thing. So what you write in the dot dots. So here's the name of the variable. So it would be new rate, for example, and it would be an integer. So yeah, we don't have floating point numbers here. So to have 1.02 here, we would actually need to say that it's a percentage. So we do this divided by 100 up. There. Um, all right. And so here we have our new rates. And for the new storage, what we return is money equals store.money. It doesn't change. And rate equals new rate. And that's it. And we have a little function now that allows you to change the interest rate. Now there's a shortcut for updating just a field here in the storage, but I'll show you that next time. For now, I think it's fairly readable. We just create a new storage which contains a variable called money, which is the same, and a variable, well, a field called rate, which is the new rate that we were given, and we just return this as the new storage for the contract. So that's the solution for this little exercise. All right, so I'll see you tomorrow for our second session, and yeah, back to you. But I think you don't have anything else to add. So this is all for me for today. Hope you enjoyed it.
Thank you so much, Suzanne, for joining. And if you have any doubt, just let us know in the comment section. Also, by chance you have any doubt and you want to ask, we have dropped our Discord channel link. Please join that, and you can ask your query and just tag @TezAsia Mentor, and we will be there to help you out. Or you can just bring your query in the doubt section. We will be happy to help you out. In case somebody wants to just make some team with anyone, they are hacking solo, but right now wants someone to join their team, or they want to join in someone's team, you are good to go. Just ping yours about your details like your skill set and other things in the team up channel. And rest, I think all the details can be found in the registration link. You can just check on this link and register for the hackathon. And then the problem statement as well as the resources and the Discord channel link all are provided here in one section. So just go through it. And if in case you still got any doubt, just ping us at the rate India Tezos, or you can just comment down in this video and we will help you out with that. Okay. Thank you so much. I think Suzanne, do we have any other thing left?
No, that's all. This is the end for now.
Okay. That's all for today's session. Okay then. See you all tomorrow at same time, 7:30 p.m. IST, Indian Standard Time. Again with the for continuing with this session in the part two of how to use LIGO Lang to create smart contracts on Tezos. Okay. Thank you so much. Tada. Bye bye. Have a nice day ahead.
Bye bye.
Bye bye. And everyone else, please join the Discord channel also, as well as the register for the hackathon. And in case if you want any other help, you can just ping on any of our socials also. You can ping me also on Twitter or any other platform. My name is Singh. And rest any other thing, just feel free to go. I will just wait for next 3 minutes and we will close the stream at 8:30 p.m.